Hello and welcome to the lecture for part one of chapter 23. So this chapter covers standard cost, and I want you to think of standard costing as really an extension of budgeting. It's a way of saying this is what we expect is going to happen, and then we can compare what actually happens to that to know if we're on the right path or not, or if we need to make corrections. So a set of standard cost are a set of norms that we're going to use to judge actual results against. So a set of norms for how much material will go into a product, how much that material might cost, how much labor might be required for a product, and how much that labor might cost, and then how much overhead is required by a product and what that overhead costs. So the plan is to, or the purpose of this is to control the cost and create some cost efficiencies. So I don't want you to think of it as a separate system. You know, we talked earlier in the quarter about job order costing and process costing. So it's not something that you would do instead of those things. It's something you would do within those kinds of accounting systems. So companies, when they determine how much material, how much labor, all of that, they can do it one of two ways. They can either do it based on ideal conditions. So in a perfect world, there's no waste, machines don't ever break down, employees don't ever take bathroom breaks, all of those kinds of things. The problem with that is nobody will ever measure up to that. It's kind of demoralizing to be working very hard and never meet standards. So most companies instead choose what they call attainable conditions. So it would be assuming there is some waste. Maybe you're looking for improvements. Maybe you're looking for improvements in labor efficiency. So maybe somebody can currently do 10 parts per hour and you're going to change their setup and you hope they can do 12 next year. So you set the standard at 12. It can be a bit of a stretch or a target, but it shouldn't be in a perfect world what somebody could do. The key to standard costing, and the thing I want you to keep in your mind as we go through all of this, is management by exception. So imagine that you're the controller in or the production manager in a facility that's manufacturing some products. There's so much going on. There's so much material being brought in and consumed, and labor and all kinds of different things going on, that it's almost impossible for you to pay attention to every single detail. So that what you want to pay attention to is the problems. So standard costing allows you to kind of separate what is normal from what is abnormal, what the issues are. So instead of looking at 1,000 transactions in a day or 1,000 occurrences of cost, you can look at the 6 that are different than what you thought they should have been and determine what the issue is. Now, in some cases, there really is a problem that you can solve. In some cases, maybe the standard was set incorrectly. And standards aren't chiseled in stone. You can change them as the circumstances warrant. So we're going to look at standards for each of the 3 categories of cost. So for materials, we'll look at both a quantity standard, so how much material should go into a particular product, and what that material should cost. We'll do that based on engineering drawings, past experience, the purchasing manager's expectation of trends and costs. We'll do all of that to set the standards at the beginning of the year. The same thing with labor. We'll determine how many hours should be, or what fraction of an hour should be required for each product. And we'll do that based on time motion studies or some mechanism for figuring out how long something should take in the factory. And then we'll base it on a standard labor rate. And again, what is our expectation for labor rates for the upcoming year? Maybe changes in minimum wage are going to make it go up, or whatever the case is. So it's future looking. And then overhead, we'll look at what our standard rate should be based on normal capacity. And I'll talk about the overhead part of this in the next lecture. So here's an example of a company that's making a pair of jeans. So the material, they believe that the standard price should be $5 per square yard. That's what they should be paying. And that each pair of jeans requires 1.5 square yards. So the standard cost is $5 per square yard times 1.5, or $7.50. So that's the standard material cost in the product. For direct labor, they pay $9 per hour. So this is probably dated information, and it should take 8/10 of an hour to make a pair. So again, you have to be careful. If it's in minutes, you have to convert to portions of an hour, that sort of thing. So there should be $7.20 of labor in each pair of jeans. And then factory overhead, $6 per hour, again 8/10 of an hour, so we've got $19.50. So when we compare actual cost against this, we're either going to get favorable cost variances or unfavorable cost variances. So if we manage to make a pair of jeans for $19.20, we have a favorable cost variance. The actual is less than the standard. If we make a pair of jeans and it's $20.22, that's an unfavorable cost variance. The cost is greater. So in this case here, we're able to compare for 5,000 pairs of jeans what the actual costs were, what the standard cost was, and you can see here that we had unfavorable variances in both direct materials and direct labor, and we had a favorable variance because the actual cost was less than standard cost for factory overhead. So the thing here is we want to split this apart. So if I spent $40,150 on materials, and I should, for making 5,000 jeans, that's how much I actually spent. I should have spent $37,500. Why did that happen? What was it? Because I paid more for the jean material because of some spike in the global market? Or did I use up a lot more denim than I should have because there were quality defects we had to cut around? So what caused that? Because those are two different problems that require two different solutions. So we're going to show you next how we can break that apart and kind of refine where the problem is so we can approach it correctly, because we're about solving problems. So all of the manufacturing cost variance, the total manufacturing cost variance, we should have spent this much and we spent a different amount, can be broken down into three variances: the direct material cost variance, direct labor cost variance, and factory overhead cost variance. So each of those variances then could be split into their components. So in that last example where we spent more on direct material than the standard indicated we should have, we could break that out into a material price variance and a material quantity variance. So how much of that difference is due to the price being different? How much of it's due to us using more or using less material than we should have? The same thing with labor. I can look at, was it due to the rate we paid people or their efficiency? And then with factory overhead, and again, I'll go into this more deeply tomorrow, it's going to mean, was it because we just ran the factory at a higher rate? So we spread our factory overhead over more parts or less parts, so kind of a volume related thing? Or was it a spending, a controllable thing? Okay. One of the things that's interesting about doing this is we can have a situation where maybe we have a favorable direct material cost variance. We spent less on material than what the standard says we should have. A lot of people would say, good, check it off, move forward. But we could have a situation where we got a really great deal on the price of the material. So we had a very favorable material price variance, okay? But we had an unfavorable quantity variance. So sometimes a very favorable variance can mask a problem in an unfavorable variance. So splitting them apart is still beneficial even when the total variance is to our favor. So for material variances, well, again, I mentioned before, we'll have a material price variance and a material quantity variance. So the material price variance is the difference between the actual price paid and the standard price allowed at the actual quantity. Okay, not at the budgeted quantity, not at capacity, but at the actual quantity we created, or that we consumed rather. The material quantity variance is the difference between the actual quantity used and the standard quantity that's allowed at the standard price. Standard quantity allowed for that level of production at the standard price. So there's two ways to show this. There's a graphic way and an algebraic way, and I'll show you both. Some people learn different than others. So this is the way I learned and the way I kind of like it, is I have these three, we call them goalposts. So on the far right on the far left, that blue box, AQ times AP, that's the actual quantity of material used times the actual price paid. So how much wood did we go through and what price did we pay for the wood, as an example. On the far right now, we're going to say, what is the standard quantity of material that should have been used for that level of production? Okay, so if I made 100 picnic tables, what is my standard quantity per picnic table? What's the total wood I should have used times the price I should have paid based on the standards I set at the beginning of the year? So the two outside pieces there are what did I actually pay and what should I have paid. Now the one in the middle is picking up the AQ from the left side and the SP from the right side. So I'll look at the actual quantity times the standard price. So when I look at the difference between AQ times AP and AQ times SP, notice that I'm holding AQ the same, and I'm looking at the difference in the price between the actual price and the standard price. So that will give me the material price variance. Now when I compare between the middle and the far right, I'm comparing, now I'm holding standard price the same, and I'm looking at the difference between actual quantity and standard quantity. So that gives me the material quantity variance. How much of this is due to, did I use more or less material than I should have for that level of production? Now the total of both variances equals my total material variance. Now the way to do this algebraically, I could do it the same way. So MPV equals AQ times the difference between AP minus SP. Now notice here, when I use less material than my standard, or when my actual price is less than my standard price, I'm going to have a negative number. Negative numbers are favorable variances because I spent less. Positive numbers are unfavorable variances because I spent or used more. So MQV is the standard price held the same times the difference in quantity. I'm going to do a couple examples of these, and I'll post YouTube videos to those, so look for that as well before you start the homework. So you'll notice something similar here. So we'll look at labor variances, and there's two variances here. The labor rate variance, how much should we pay people, and the labor time variance, how efficient were they? So the labor rate variance is the difference between the actual rate we paid people and the standard rate we should have paid them times the actual hours they worked. The labor time variance is the difference between the actual hours worked and the standard hours that should have been worked for that level of production at the standard rate of pay. Again, we can look at it two ways. So here on the blue box on the far left, we have actual hours times actual rate. Okay, so that's, you can see the pattern is similar to quantity times price, but here we've got hours times the pay rate. And on the far right, we've got the standard hours that should have been incurred for that level of production. Not what our budget was, not our capacity, but for the actual level of how many parts did we make, how many hours should that have taken, times the standard rate, how much should we have paid workers. So again, in the middle, I pull the AH from the left side and the SR from the right side. So now I'm holding the hours the same, and I'm looking at the difference in rates. That'll give me the labor rate variance. And again, did I pay workers more than what I intended or less than what I intended? Now when I compare the difference between the middle and the far right, I'm holding the standard rate the same, and I'm looking at the difference in hours. So were they more efficient or less efficient than what my plans were? That'll give me the labor time variance, which gives me the total variance. So again, I can show it algebraically. So here, the labor rate variance is the actual hours times the difference of the actual rate minus the standard rate. And then the labor time variance is the standard rate times the difference in actual hours minus the standard hours. And then the total labor variance is the two variances above together. Keeping in mind, a negative number is going to be a favorable variance. Positive number means more spending, unfavorable variance. So I'll post two videos, one for a material variance and one for a labor variance. And so please take a look at that, and we will pick up where we left off here and get into factory overhead variances on the next lecture. Thank you.